Okay, so the last topic about curves is how to find the length of a curve and specify a curve via the arc length. So let me just explain this quickly. The idea, say, imagine that you have a curve like this, and you have a time in t0, and you have a time t1, and you want to find the length of this segment of the curve, right? So the length, say, from t0 to t1, so let's call it L of t0 t1, length from t0 to t1. Well, what is length? Basically, it's just like integrating. If you have a particle moving along this curve, right, from this point to this point, the distance traveled is approximately the length of the displacement vector, right? But the length of the displacement vector is the same as the length of the velocity vector times the time that it took you from moving from this point to this other point. And so that's just the same as the speed times the small time interval. And so the length really is nothing but the integral from t0 to t1 of the speed times time. Okay, so this is the formula that you need to know. And so, for example, what would be the integral, like the length of a circle of radius 2r? Well, we know that an equation for the curve is just r cosine of t, r sine of t, where t goes from 0 to 2 pi, right? The velocity of this curve is negative r sine of t, r cosine of t, and then the speed is just r. And so the length would be the integral from 0 to 2 pi of the speed, which is the integral from 0 to 2 pi of r dt, which is 2 pi r. So that's how you find the length in general. The arc length is basically the length, but where now you think of this endpoint as variable, so it's like a length changing in time. So what I mean by that, what is arc length? So again, the idea is to have a curve now you have a reference point, which is time t equals 0. So this is a reference point. And then you have another time, which is t. Okay? And then the length of this segment now depends on t, because t is allowed to move. So s of t is called the arc length, and that's just the length of the curve from time t to 0, from t equals 0 to time t, to an arbitrary time t. Okay, so for example, that means that in practice, I'm using notation. You can think the formula for the arc length will then be the integral from 0 to t of the speed dt. It's a bit abusive because, like, maybe you should use a different letter here, but it won't cause confusion in practice. So, for example, if the curve is t squared minus 1, 2, then the velocity is 1, 2t, 0, and then the speed is 1 plus 4t squared. And so the, okay, do we know how to integrate this? I don't think we do. So, not in an easy way at least. So, okay. Well, what do? Oh, okay. Sorry. Small change so that it works. That's the speed, and that's square root of 2 times t. Good. And so the arc length is just, so basically the things that you have to think that I have to integrate the speed because of this formula. So it was not easy with the form the thing that I wrote before. The speed is the integral from 0 to t of 2 root 2 t dt. And that's like, this is t squared over 2, so it's just root of 2 t squared. Okay, so that means that the distance traveled, the distance traveled along the curve from time 0 to some arbitrary time is root 2 times t squared. Okay, and so in practice, one way in which you think about this formula is that it gives you the distance in terms of time, and so you can reverse the roles and use this equation to solve for t. And so you can say that s over root of 2 equals t squared, and so t equals root of s over 4th root of 2. Okay, and so that allows you to write the equation. So instead of specifying a point on the curve by the time, you can specify a point on the curve by the distance traveled from a reference point. And so what that means is that you can write r as in terms of this new letter s. So you can say that r now is a function of s, which is t squared. So t squared is s over root 2, t squared minus 1, which is s over root 2 minus 1, and then 2. Okay? And why would you do such a thing? Because in general, what would be the derivative of the derivative of r with respect to s? Well, this would be the derivative of r with respect to t times the derivative of t with respect to s, because this is just a chain rule. Okay, this is the velocity, and this is like 1 over ds dt. But if you look at this formula, that's like by the fundamental theorem of calculus, that's like the speed. So that means that this is velocity divided by speed, as this is a tangential vector. So that means that if you write a curve in terms, and this is more or less general formula, so that means that if you write a curve in terms of the arc length, then you get that the derivative of the equation gives you the tangent vector. So if you write curve in terms of arc length, the derivative gives you the tangent vector. So basically, you can think of using arc length. When you specify a curve in terms of its arc length, is basically as if you were moving along the curve at unit speed, so that the velocity vector coincides with the tangent vector. That's why it's somehow useful to use arc length, but we won't insist on this too much for this course.